Buongiorno a tutti, sono molto contenta di avere l'onore di introdurvi due persone che eccezionalmente sono connesse con noi oggi grazie alla disponibilità anche dell'ufficio di IceCube Education and Outreach, che investe molto tempo per in qualche modo riuscire a portare diciamo, nelle case di tutti noi diciamo, l'eccezionalità di questo luogo, che è la stazione del Polo Sud, e anche delle attività che vengono condotte lì. Oggi sono con noi presenti due persone che voi vedete con il nome di Winterovers, e Winterovers è una parola che identifica quelle persone che lavorano nella stazione del Polo Sud, e si chiamano Winterovers perché tipicamente appunto rimangono nella stazione per un tempo molto lungo che copre appunto tutto l'inverno antartico. Questo perché la stazione non è accessibile tutto l'anno, è solo accessibile nel breve periodo estivo, che è attualmente il breve periodo estivo, che inizia appunto a novembre e termina a febbraio, appunto siamo nell'emisfero opposto, e che è l'unico periodo in cui è possibile atterrare con degli aerei e quindi scambiare persone e materiale. Quindi in questo momento la stazione si trova in estate, dove normalmente appunto c'è una grande intensificazione delle attività, sia appunto per quanto riguarda l'operazione degli strumenti, ma anche per la preparazione del lungo inverno di totale isolamento. E in questa fase c'è anche tipicamente un cambio di guardia, no? Un passaggio di testimone tra persone che hanno già trascorso un intero inverno, come nel nostro caso John Hardin, che sta indossando la mascherina nera, e i nuovi Winterover, Martin Wolf alle sue spalle, che è arrivato appunto solo 2 giorni fa. Ora quest'anno è un po' più eccezionale del solito, perché alle difficoltà logistiche, diciamo, tradizionali per l'ambiente del Polo Sud si è aggiunta anche la pandemia, e per questo motivo non c'è un grande ricambio di persone, e infatti John Hardin ci ha appena detto appunto che lui trascorrerà anche tutta l'estate nella stazione, cosa che normalmente appunto non avviene. Questo è necessario perché le persone che sono appena arrivate, a seguito appunto dei limiti nella mobilità, non hanno potuto ricevere la preparazione, il training che normalmente viene diciamo, impartita appunto ai Winterover, e sono arrivati diciamo, con diverse difficoltà, e in un qualche modo devono adesso, durante il periodo estivo, imparare tutto quello che non hanno potuto imparare diciamo, nei mesi di preparazione, prima di raggiungere la stazione. Martin ci ha appena raccontato che il suo viaggio per arrivare al Polo Sud è durato 2 mesi, questo a seguito appunto di varie stazioni e di varie fasi di quarantena che lui ha dovuto fare, ed è appena arrivato, è arrivato 2 giorni fa. E questo ha un significato un po' particolare, perché considerate che il Polo Sud si trova ad una alta quota, siamo circa a 3000 metri di quota. Poi, considerando le condizioni, diciamo, fisiologiche estreme di temperature molto basse e di pochissima percentuale di umidità dell'aria, respirare è molto difficile. Quindi arrivare al Polo Sud si arriva attraverso un volo che dura dalle 2 alle 3 ore, partendo dal livello del mare e arrivando ad una quota che fisiologicamente è superiore a 3000 metri. Quindi lui ha delle oggettive difficoltà respiratorie in questo momento. Ci vuole circa una settimana per riuscire in qualche modo a riadattare il proprio fisico alle condizioni estreme. Quindi il fatto che lui sia presente oggi è veramente un grande gesto anche di disponibilità nei nostri confronti. Va bene, ora detto questo, se avete delle domande da pormi, vi prego appunto di alzare la manina oppure di scrivere, e altrimenti io lascerò la parola ai nostri Winterovers. Okay, I don't see any questions, so I would let now John and Martin take the mic and guide us through this adventure.
Okay. You said you had my slides up there somewhere? Hopefully. If
yes,
not,
I will share them now, okay?
Okay, perfect. Okay. So, hi everyone. As I believe you heard, I'm John. I'm Winterover from 2020. So I've been here for a little over 12 months now. This is Martin. He has just gotten here although he's actually wintered before in 2017. And so we're here to tell you a little bit about IceCube and a little bit about life at the South Pole. So without further ado, can we go to the next slide, please? Let's see. Can we go to the next slide, please? Can you hear me? No?
Sabine, si è bloccato
Maybe I can't see it.
Si è bloccato.
Ti è bloccato perché io sono andata avanti. I changed the slide, so it's.
È bloccato sulla prima slide.
Oh.
No, I went ahead. I'm on the third slide now. Let me.
Oh, I'm sorry. Yeah, I just can't see it from down here.
No,
I'm gonna have to.
Okay, so you don't remember. You can't see that I'm changing.
Yeah, it's probably our internet. Making life a little difficult for us at the moment. There it is.
Okay.
Now I'm seeing you.
Okay, I'll just do it in this mode. Okay.
Okay, thanks. Sorry. So a little bit about how to get here. You have to go to New Zealand first for the US Antarctic program. And from there, you fly to the coast. Our coastal station is called McMurdo. And typically you do that on what's called a C-17, a very large plane we don't have pictured here. Then from McMurdo to get to the South Pole proper, which is 900 miles away, or I don't know, what is that, kilometers? 1,800 kilometers away. You typically will take the plane pictured in the upper right here, called a LC-130 Hercules. And there you can see our station manager standing in front of it. Although if it's very early or late in the season, or if it is this year specifically, you will get here on this plane in the upper left, and that's called a Basler. It's a much smaller plane, but it's easier for that to travel. When you're waiting for the plane, you will wait in this small box, so you can see the international terminal. And then when Yuya and I got here, we went out to the geographic South Pole. We went and took a picture, and there's us more than a year ago now, when we just got here and hadn't learned how to keep ourselves warm yet. So next slide, please. There it is. Just a little bit about the station. We call it the elevated station because it's on stilts, and that allows the wind to whip under it. And when it whips under it, it's supposed to reduce snow accumulation. That said, we are also at 9,300 feet of elevation, which is, I believe, almost 4 kilometers, if I've done my math right real quick in my head. I'm sure Martin will correct me. So the air here is quite thin. It's about 2/3 of the atmosphere at sea level. The station proper is 65,000 square feet, quite large, plenty of room to live, work. In the winter, there's 42 people, approximately. In the summer, it can get above 150, although this summer, I don't think we're getting above 70. And we use 450,000 gallons of jet fuel. And I think that comes out to 2 million liters, approximately, each year to keep the station warm and keep the power on. Most of that fuel gets dragged in these bladders that you see in the upper right. They come here, they make what's called the South Pole Traverse, overland traverse, and it is much cheaper to get fuel here that way than otherwise. Lower left, you see our galley. Our galley is much more sparsified right now, both to satisfy distancing requirements and because there are fewer people here. But the food here is excellent. It's really tasty, plenty of variety. In the lower right, you see one of the larger rooms, the rooms you get in winter. And that you can tell because it has 4 ceiling tiles across instead of 3. But the rooms are actually very nice. You do get your own room. So next slide, please. A little bit about inside the station. You see our gym here. You can play all kinds of stuff in there. They play volleyball. We watch movies, which you see in the upper right. One of the traditions is at station close, we watch all 3 versions of The Thing in a row immediately when it closes. It's a fun time. Lower left, you can see me actually in the ICL. We'll talk about what that is in a little bit. But we're putting up covers because we have some Aurora cameras on the roof of the station, and they are very sensitive to light. So we don't want to let any of our light from inside the station spill out onto the snow and contaminate the science. Now, in the lower right, you can see sunset dinner, which is the first real big dinner with the winter crew. And it's when we all kind of get to know each other, and the galley does a big to-do. I think it was a 7-course meal this time or something. I think our midwinter was 4.5, but I think Zeke kind of went all out for our sunset. So it's, like I said, we eat well here. Next slide, please. This is outside the station. I mentioned it was elevated in the upper left. You can see it's sort of shaped like a wing, and it is successfully whipping snow under there, but eventually the snow accumulation will get to us. The upper right, you can see the New Year's tradition, which is where we go out and reveal the new pole marker. Because we are on a gigantic glacier, it's moving approximately 10 meters per year. And so the location of the geographic South Pole is moved to reflect that on the new year. And when it's done, we put a new South Pole marker out there that is voted on by the previous year's winter crew. The lower left is pictures of all the previous pole markers from all the previous years. The pole marker is actually a closely guarded secret until it is revealed on November 1st. So I know what the next year's will look like, but only 41 other people do. So lower right is a picture of our power plant. You can see 3 generators there. The generators are very near and dear to us. We only need to run on one of them, and it's very important that they stay running because that's how we stay warm. So next slide, please. A little bit about our greenhouse. So between February 15th and late October, early to mid-November this year sometime, there are no flights to the South Pole, which means that any fresh food we have to grow here. As a result, we keep the greenhouse. The upper left is a picture of the greenhouse with the full spectrum lights on, but it's a little sparser than it looks right now. We were in a germination phase more than a harvest phase. We grow all kinds of stuff in there, cucumbers, lettuces. We even successfully grew a strawberry, more than one strawberry this last winter. And we're very proud of that. It's a great place. I spent a good amount of work there. So next slide, please. This is just a little bit of how holidays at the pole looked. This is, of course, before social distancing requirements. I should mention that you see Martin and I wearing masks and distancing here. We are doing that because there has been a plane that has arrived to McMurdo recently enough with passengers that are here. Once that time period ends with no problems, we will go back to not just being cautious, but not extremely cautious down here. But until that time, we're all wearing masks and distancing, and in public space, when we're in public spaces especially. Okay, so back to the fun stuff. So Christmas at the pole and holidays in general, like I said, they go all out. This is the dessert table for our Christmas. They actually took volunteers to bake Christmas cookies, which for me was wonderful. I was missing home quite a lot. Missing the holidays with my family hit me pretty hard. So it was really nice to do some traditions. And then also we voted on the gingerbread houses in the upper right. And the winning gingerbread house is on the front of the dessert table there. It's a model of the station. Like I said, they really do a lot to make it special here. We're actually postponing Thanksgiving a little bit so that we can all eat together. Next slide, please. A little bit about the weather. It's variable. It delays planes all the time, but it is really, really cool. The temperatures here are very cold. They're always below freezing. And in the winter, they can get to -70 C, -73, or even 74 C, actually, I think is our minimum recorded this winter. That said, in the summer, the weather reporting is more important because that's when planes are landing and they need to know that they can land and they've met all their minimums. The lower left here, you see one of our summer meteorologists. His name is David DeCoux. He is now working on Mount Washington, which likes to brag that it has the worst weather in the world. You know, we'll give him that. The upper left is a picture of the sunset behind the ICL. That's our building that we have out in the dark sector. And the lower right is actually David launching a weather balloon. They do that anywhere from once a day to 4 times a day, depending on if they need plane data or if they don't. So next slide, please. A little bit about fun down here, especially during the winter. When we got down here, we went and took a winter survival class. There's a 30-kilo bag you can get that contains enough gear to keep you and one other person alive for 3 days in Antarctica. These are on all the flights, and you take them with you when you go out into the field. It's more relevant at McMurdo than here, given that we typically don't venture too far from the station down here, but it was still fun to learn. The middle here, we have Walk to Mordor with my fellow Winterover, who has now left and is going back north, Yuya Makino. He is participating in the way PhDs should in the Walk to Mordor by not walking. But everybody else decided to watch all 3 extended edition Lord of the Rings movies and stay on the treadmill the entire time. Upper right is the tradition of Wisconsin, the Wisconsin Badgers. They've had a presence at the pole every time they have been in the Rose Bowl. And so this is the 3rd time they've been in the Rose Bowl. And so we put together a greeting for them. And we got some fans who weren't down here through the Wisconsin program to come out with us. It was fun. Lower left, the big red is the iconic wear in Antarctica. But a lot of the people will actually wear the Carhartt jacket. And that's because it provides better mobility and it is almost as warm. So unless you're walking long distances outside, it's just good enough. And then finally, at the lower right is me and Yuya playing chess at the edge of IceCube. And since he's not here anymore, I can tell you I'm pretty sure I won that game. Next slide, please. Little bit about the end of summer. So we were waiting for packages. Logistics here are challenging in any year. This year, they're especially challenging. So we eventually got all of our packages right before station close, like within a week or so before station close. On the right, you see a picture of the inside of an LC-130. Well, I came here on a Basler. We were allowed to go for R&R, relaxation and recreation in McMurdo. And so we spent a few days there. And when we did, we took an LC-130 there. It was a fun time. I got to see penguins and seals and wildlife and walk some trails. Highly recommended if you ever winter for a full year, take some R&R time. Upper left is the very end of summer. This is actually after sunset behind another one of the telescopes in the dark sector, the SPT, or the South Pole Telescope. They have a nice moving dish and they get all the pictures taken of them. So next slide, please. These are more pictures of sunset around the ICL. Another thing I should mention, most of the photos in here, especially if they are good, were taken by Yuya. Yuya is an excellent photographer, though he would never admit it. Just keep that in mind. Next slide, please. These are some more pictures of sunset with the moon, twilight. Oh yeah, the bottom picture here, that is actually the moon. So to get good, it's so dark down here that to get good pictures, you really need a very long exposure. And when you do, the moon will actually wash out a large fraction of the sky. It was a point of annoyance for us that the winds and the clouds would clear only when the moon came up, and it made it hard to get good pictures of auroras and stars and whatnot. But we got some good ones. Next slide, please. Like I said, we got some good pictures of auroras. So one of the best parts about being down here is seeing the first snippet or little wisp of a cloud in the sky. You get to see some of the aurora going. It's just beautiful. You get to walk outside, you can look up, you see the Milky Way and the stars orbiting around. Because we're at the South Pole, they make a perfect circle in the sky. They're not offset and rotating throughout the year. It's always just the same orbit they do. It is really, really cool. It was my favorite part of the winter, is seeing the sky. Next slide, please. A little bit about the science down here. The science comes in primarily 2 of the sectors. One is called the clean air sector, and that is where NOAA monitors atmosphere. It's some of the most well-mixed air in the world, and it has the least direct human influence. So they get very steady readings of CO2, of CFCs, and those sorts of things. The other sector the second sector that I wasn't counting the first time is the quiet sector, where we completely minimize vibration for earthquake studies. And then the final sector, obviously the best sector, because that's where IceCube is the dark sector. And this is where we're trying to do everything we can to minimize radio waves. Though there are 2 cosmic microwave background telescopes out here, actually 3, 2 cosmic microwave background projects out here. And there's also IceCube. And IceCube is the largest, but it is under the ice. So the ICL is what you see in the upper picture here. And it is where all of our servers live that process all of our data that we take. The lower picture is SPT, the South Pole Telescope, along with the 2 summer grad students, although one of them now has a PhD and is wintering this year. And then BICEP, not pictured here, is another cosmic CMB telescope that sits out here. So next slide, please. A little bit about the ICL. So we have 86 strings, and our strings are arranged in a roughly hexagonal pattern that is where they're about 100 meters apart. So you get a bunch of equilateral triangles with 100 meters on each side. And what this means is we have close to a cubic kilometer of space instrumented. So we start about halfway down the ice before we even have detectors down there. And then we put 60 detectors on each of those strings. Each of these is sort of like a really big, really sensitive pixel. It's a photomultiplier tube, but that's how it works. So all of that data has to be integrated. We have more than 5,000 DOMs in total. And to do that, we have a whole bunch of servers and a whole bunch of data acquisition computers we call DOM hubs. The DOM being the digital optical module that is the pixel I referred to earlier. The ICL also serves as kind of a clearinghouse for cargo and all sorts of things like that. So we typically will support other experiments during the summer, although again, the summer's special. Next slide, please. So a little bit about the science, and then we'll go to Q&A, which is my favorite. I'll try not to be too long-winded on this. It's very easy for me to go long. So next slide, please. Like I mentioned, the detectors don't really start until halfway through the ice. As you can see, they go all the way to the bedrock at the bottom of the ice. The ice down there is very clear. You can see all kinds of light. So this just gives you some idea of scale and what's going on. One thing to note, just because I like dwarfing SPT and BICEP, if you look up top, you see the ICL in the middle there. About halfway to the edge, you see DSL, which is the building where SPT and one of the BICEP sits, and MAPO, which is the building where the other BICEP sits. So we are quite a large experiment. Next slide, please. A little bit about how this works. So the way we detect neutrinos is that when a neutrino interacts with our detector, what it does is it will turn into a charged particle. And you may have heard that you can't go faster than the speed of light, but as it turns out, you can go faster than the speed of light in a medium. Because you may have also heard that if you stick a pencil in a glass of water, it looks like it's bent because the water is going slower, or the light is going slower in the water. Now, when a charged particle is going faster than the speed of light in water, not in a vacuum, just in water, you get the equivalent of a sonic boom, you get an optic boom, which is a bunch of photons coming out in a big cone. And that is actually what our sensors are picking up. Now, neutrinos interact only with the weak force, and turns out scientists aren't terribly creative. The weak force is very weak. And so they almost never interact, which is why we need to have so much stuff for them to interact with in order to have a chance of detecting them. So next slide, please. So what do we actually see? These are a little bit of the sort of pictures we see in the detector. The size of the sphere is the amount of light that DOM saw, and the color is when it saw it. So it turns out that different types of neutrinos will turn into different types of subatomic particles, typically an electron, a muon, or a kaon. And the electrons, they stop really fast, so they tend to make big bulbs of light, whereas the muons go straight through. And what they will do is they will make a direct path and leave light there. And that gives us some information about the neutrino and how much energy it had and where it came from. And so we use these patterns and this timing inside the detector to point back and characterize the neutrinos. So one fun thing about the electron here is you can tell that it's a neutrino by eye. And the reason you can do this is because there is no particle that exists other than the neutrino that could get into IceCube with this much energy and not leave a signature on the edges of it. So this came in, interacted in the middle of IceCube, and then left all of its energy there. And neutrinos are the only particle that can do that. Next slide, please. A little bit about why we care about neutrinos. We have all kinds of stuff coming from space. We have all kinds of muons, although those are mostly coming from the atmosphere. But the nice thing about neutrinos is they fly straight. And so whatever's coming from cosmological, anything else, anything charged is going to get bent by galactic and intergalactic magnetic fields, whereas neutrinos will not. Now, here, this slide is a little bit more about signal and background. So we have to worry that neutrinos get produced by these charged particles that I'm talking about in our upper atmosphere. And so as a result, we have to find a way to filter out these huge amounts of atmospheric neutrinos, which look exactly like what we're looking for, as well as atmospheric muons, which do not. Those are a lot easier to filter out. But we're performing a pretty difficult task to find only things that came from astronomical sources or astrophysical sources. Next slide, please. This is a little bit, one of the cooler things we've discovered was a point source. And we were able to back it out and point directly at a galaxy with a gigantic black hole and find that it was happening we were getting neutrinos at the same time that things were going on with this black hole. So we know that whatever's going on there produces very, very high energy neutrinos. And because we're a telescope, we're more about looking around and discovering, and it's cool what we can see. So next slide, please. Yeah, that's kind of the end of the presentation, but please ask any questions. I'm happy to answer questions about science, and I love to answer questions about the South Pole. When I was training for this job, we had all kinds of questions for our boss. So it's fun to just see what you guys want to hear about.
Okay, thank you very much, John. We have already one question, and I encourage everyone to formulate and ask questions. A tutti i ragazzi vi invito appunto a formulare le vostre domande. Se non le volete formulare in inglese, le volete formulare in italiano, va benissimo. Potete utilizzare appunto la finestra predisposta, oppure se volete addirittura alzare la mano e vi apriamo il microfono, lo potete formulare da soli. Okay, one first question is it hard to live there? What made you stay so long in such an isolated place, far away from your loved ones? Are the curiosity and the love for science enough to do this kind of life?
So for me, the opportunity to contribute to science and the opportunity to be down here in such a remote and unique place was enough. But as I said, it actually was rather difficult. Especially birthdays and holidays and things where you're traditionally with family. I don't know if I could make a lifetime career out of this, but it was absolutely worth it to come down. I might want to let Martin opine on this too, since he's coming down for a second winter.
Yeah, hi. So I'm Martin. For me, living in the South Pole is, I think it's pretty okay and pretty relatively easy, I think. Of course, I mean, you're far away from friends and family, but I mean, we have nowadays we have internet, and you can talk, have phone, you can talk to people in the north, and so that's so much. That's so that you can keep in contact with your friends, and so yeah, I really like it here. It's a really great opportunity. I did already winter in 2017, and that was a great year. I had very great people, and also looks like the next year. So we also have really nice people here, and I'm pretty sure that we're going to have a really great winter again. And John also said he also had a really nice winter, and so I'm looking really forward to kind of the night sky with all the stars and the lights, and yeah, so it's really great. And so this year, because of the whole COVID situation, IceCube was looking for people that were already wintering in before, because we had because the training situation was very difficult, because we did all our training online now, and so that's why it was really important to have somebody down here that already had the hands-on in the previous year. So that's why they asked me to come down here, and I said, yeah, of course, I really like it here, and so yeah, so I'm back here. So
Okay, thank you very much. You're also doing an exceptional experience, so maybe also doing something exceptional, which you don't have opportunity elsewhere to do, is also part of it. No, maybe you don't want to say this, but I believe it's also part of the thrill. Okay, so now next question is the average amount of astrophysical neutrinos you detect at IceCube constant every year, or is it changing? If so, is it following a pattern?
So, as far as we can tell, it is constant. Now, the trick to this is we detect about 10 per year. And it turns out that when you're averaging 10 per year, the uncertainty on the number you're going to detect from year to year is quite high. You're looking at maybe 30% standard deviation. It's not even arguably a Gaussian at that point, or a bell curve. So it would take quite a few years to really detect a trend. Now let me plug the IceCube upgrade. We're hoping that in the next 5 to 10 years, we'll be able to upgrade IceCube to cover almost 10 times as much area. And then we'd be looking at detecting somewhere between 50 and 100 astrophysical neutrinos per year.
Okay, thank you. Then the next question is, has climate change affected or threatened your activities in any way?
So here at the South Pole, we are cold enough that we will stay and be at well below freezing for a long time, no matter what happens as far as climate change. Even some of the most pessimistic scenarios should keep us below freezing. If we were to go above freezing down here, it would be very bad. That said, it does affect a little bit of the weather as far as I'm aware, and it might affect the flight schedule. And it also affects McMurdo, which is our staging area and where we are supplied from, and supplied through, I should say. I don't know specifically what they're expecting, but melt there is not good. It messes with, they land on ice typically for most of the season. And if that ice gets soft, it affects what kinds of planes can land and that sort of thing. So yeah, it's not good.
Okay, thank you. Then the next question is, do you ever get bored or tired of your job? And how did you become scientists?
Okay, so I'll do the board first. Down here, you would think you'd get bored, but honestly, there is plenty to do. I really was never honestly bored. I actually brought down plenty of things to keep me busy and did not get to most of them because there were so many events going on station and so many different things to do. Working in the greenhouse, working out, hanging out with people in the evenings, playing board games, that sort of thing. I really was never bored. As far as how I came to be a scientist, my dad really influenced me in middle and high school. And then I went to undergrad, studied physics, and I found out in the course of studying physics that they would pay you to go to grad school. Wouldn't pay you much, but they would pay you. And it sounded like the thing for me to do. And I've really enjoyed it, never looked back.
Okay, thank you. And the next question is, how long has it taken to build a station? How were detectors installed on the rock surface, drills, or whatever?
So the station, I believe, took what, 5 years to build, something like that, 5 or 6. It's the old station was a dome. You may have seen pictures of it. And this new station is, as you can see, not a dome. Looks like a big E with 4 legs. And yeah, I think it took 5 or 10 years. I think it's actually like 6 or 7. But they built it in stages. They brought a ton of people down. They were doing something like 4 times as many flights as they do nowadays. It was an enormous undertaking, but it's a really nice place to stay. So I think it did its job. Now the IceCube, I believe the question was, how long does it take to deploy IceCube? Was that it? So
sorry, the question was how was the detector installed on the rock surface? So I believe that they wonder, that there is rock and how the whole thing holds.
So the way the detector was installed is we're actually, like I said, on 4 kilometers of ice. So we used a hot water drill, or I should say I was not around then and actually quite young. They used a hot water drill to melt the ice in a gigantic cylinder. And then what they did is they had strings with domes on them that they lowered into that hole of water, and they let it refreeze around it. So they drilled all the way to the bedrock, and they just left it filled with a water column. And then they just lowered a string into that water column and let it refreeze. And they managed to do this, all 86 strings, I believe, in 6 summers.
Okay, the next question is, how did you manage the COVID-19 epidemic? Were there any problems related to infections?
Thankfully, no. Our station closed on February 15th, and there was nobody in or out after that. And as a result, during the winter, we actually did not have to take COVID precautions. Now that new people have come in, we are actually taking very strict precautions. You may have heard Martin mention that he quarantined for more than a month total, although I believe the required time is something like 2 or 3 weeks total, 3 or 4 weeks total. But flight delays resulted in more than a month. And even so, the new people coming in, once they get to McMurdo, it's still a 7-day quarantine for any station they are at. So that's why we're wearing masks now and why we're trying to be careful. That said, there have been no infections on Antarctica. So we're pretty confident that our procedures are working.
And then I think somebody is wishing to become a Winterover and is asking, what are the graduates of people who work at the base?
So there's all kinds of different ways to be a Winterover. The science staff here is actually a relatively small fraction. I believe there are 10 technical scientists working down here of the 42 people. So there's people who work in supply, there's people who work maintenance, there's the galley, our chefs and our bakers. The scientists are typically some variety of PhD or engineer. Everybody else is being well qualified for whatever job is needed. So it ranges wildly depending on what job you're doing. You also have to be willing to come down here. That's probably the biggest qualification, or one of the biggest qualifications.
What's a typical day like?
So during the winter, a typical day, for me at least, wake up, check on the detector. Typically, there's some small task or another that the North needs done. Then go to lunch. The afternoon, keep an eye on the detector, but while I'm doing that, probably work out, do a little bit of reading, talk to some people, go work in the greenhouse. Then, you know, somewhere in there you eat dinner, and then after dinner, people hang out. The winter is relatively chill, especially for scientists. Although I should say that we will also occasionally get woken up in the middle of the night and have to walk more than a kilometer in -70 to go fix whatever needs to be fixed at our building. So it's not all sunny, but most days it's you're doing tasks, and it's good if you're not busy because it means data is being taken.
And you seem to have found a job that you love and enjoy doing. Do you have any advice for students who have to choose their university pattern?
So my advice, especially if you're looking to go the academic route, this might be more relevant in the US than Europe, honestly, but try to graduate from undergrad without debt, and then go to graduate school. It's in the US, at least, I had the option to go to some very expensive undergrads, and I did not. I chose to go to a place where I was able to get a scholarship, and that was far and away the best choice I could have made. Like I said, that may not be quite as relevant for people in Europe. That said, also study what you love. Make sure you do undergraduate research. If you have the opportunity to do research in with a lab or with a group, do it. Make sure you get to know people, you understand what you like to do. For me, I discovered I loved electronics. I thought I wanted to be a theorist, but then I started working with my hands, and turns out I love that too much. So make sure you try a lot of different stuff in undergrad, and just be ready to pivot and change fields and change what you want to do. Be ready to explore. But do the hard stuff. Is between those two, somewhere between those two facts should get you where you want to go.
Elisa, I think there's someone who wants to put a question on the microphone. I will open his microphone. So Giacomo Torre, ti apro il microfono adesso. Sì, ok, ottimo.
Okay. Hello. First, consideration. I think that you are not so different from the future astronautics that will go to Mars, because the situation for you is very, very original, very far from the normal situation about us. And then the question, would like to know if you know something about the radiation amount in that place because of the thinning of the ozone layer.
Yes, so first off, I should say we have several people down here who actually applied to the astronaut program on basically the same theory. I should also say, because it's a point of pride for people at the South Pole, that it is harder, or it takes longer to get to the South Pole than it does to get to the ISS. And it takes longer to get from the South Pole than to get to from the ISS. But that's just a different story.
Yeah.
Now, as for the radiation, there would be an issue with the UV, although the sun is below the horizon 6 months out of the year, and it never gets above 23 degrees. So while the ozone layer is thinning down here, it's not a huge issue. Also, you almost never leave any exposed skin outside. It's a quick path to getting frostnip. Even in the summer, it gets real cold real fast. I did the marathon last year, and I left the very tip of my nose undone, and I got a bad sunburn. That's the only time I've gotten a sunburn.
Okay, thank you.
Okay, another question is: does everyone have his own task, or can you can do everything?
So there's two answers to that. So everybody has their own tasks, but there are tasks that are communal to the station. So typically things like taking care of the greenhouse is something that you volunteer for, and anybody can volunteer. There's a rotating schedule of washing the dinner dishes. Every weekend, we all clean the station. It's called House Mouse. So between all of that, you can always volunteer for more stuff. In fact, sometimes you have to shovel the snow, and you do indeed shovel snow at the South Pole.
Next question is, as you said, magnetic fields do not affect neutrinos, but don't they affect the corresponding charged particles detected by the optical detectors? Then, how do you shield the detectors from external magnetic fields?
So this is an excellent question, but the answer to this is that the magnetic fields that bend charged particles are on intergalactic scales and even on Earth's terrestrial scales, the Earth's magnetic field. They're very weak, and the reason they bend them is they are able to act over extremely long distances, astronomical distances. IceCube is only 1 kilometer long, and the particles that are there are extremely high energy. So it turns out that the effect of the Earth's magnetic field over that length scale is negligible. However, this has been a problem for other experiments I've worked on for charged particles, and typically what you do is you put a metal cage around them.
Thank you. And has isolation affected your mental and physical health?
That's a good question. I don't think isolation has done that much to my mental health directly. It has affected my sleep schedule. It's made it a little difficult to maintain a constant one. And for me, I don't do so well on lack of sleep. But other than that, I think I've been mostly okay. You can be the judge. It's pretty hard to judge that yourself.
I think you're doing pretty well, actually. How are you provided with electricity? Do you use any renewable energy resources?
So this, we do not, unfortunately. We are provided with electricity via, we burn jet fuel, and that powers a generator which makes electricity. We've talked a lot about using wind energy down here. It gets so cold though, it's actually rather difficult to make moving parts. The other thing we've talked about is nuclear energy. We are an ideal candidate to have nuclear energy at, being remote, and it would be wonderful, although there's significant question in it. It's actually quite arguable that that's prohibited by the Antarctic Treaty. So this is something that comes up every year that people talk about and think about.
John, can you say a few words about the Antarctic Treaty? I'm not sure that everybody is aware what it is and why and what it means.
So the Antarctic Treaty is a treaty among, I believe, I want to say it's 11 nations. Much more now. Originally among 11 nations, and it's been signed on to more. And what it is it's a treaty about how we're going to treat Antarctica. And it says no one will claim Antarctica as part of their territory. It says, there will be no military on Antarctica. It's exclusively for scientific use. And it also bans nuclear, I believe, in some capacity. I believe it bans nuclear development technically, so there might be some loophole there. There's something, it's not, I don't fully understand the legality, but it's there to protect the continent for scientific endeavors rather than have people fight over who gets to claim what on the last bit of land on Earth.
Is it expiring or is it renewed? I thought it was for a limited time. What's the destiny of this? Do you have an idea?
It is up for renewals too. I'm not sure when, but I think maybe in the next decade or so. And 2025 is what Martin's saying. He also wanted to make the point. I don't think you can hear him over my mic, my sad little laptop microphone. He wanted to make the point that it's there to preserve the wildlife on the coasts as well. There's no wildlife at the pole. Humans are the only animals dumb enough to live down here. But on the coasts, it's important.
Okay, thank you. The next question is, are you happy to go back home or would you like to stay there again?
I'm torn. I'm going to be very happy to go back home and see my friends and my family and girlfriend, and it's going to be wonderful. That said, I really loved being down here. This is a kind of life that's really nice. And that said, I need to go back and get back into academics. I really want to go back and do science, write papers, talk to people on a regular basis. So, like I said, I'm very torn about it. I do like it down here.
Great, thank you. And what's the weather like?
So right now it's very warm. I think it's about minus 25 C out there. And I went out with just some gloves and a hat and just this shirt, just this fleece on to say goodbye to our weather guy who was leaving today. And it was real warm. The sun was shining. Can't complain.
But how warm is warm? How many degrees?
Minus 25 Celsius.
Okay. Do you have the possibility to show us outside, or do you have a desktop computer? I don't know if you can turn your camera on the window and we can see anything outside.
So let me see what I can do. The trick is getting this to expose properly. Yes, there we go. There's the window. There is outside. That little building you see out there, that's MAPO and DSL.
It's fantastic. Thank you so much.
Can you see the ICL? I think. Let's see if we can see it.
We could see it pretty well, actually.
Yeah. There it is. There's the ICL way in the back. The ICL is a little over a kilometer away, so it's pretty small from this distance.
Okay, we have another question. Do you always feel up to what you are doing? Have you ever been afraid of discovering something totally unexpected?
Ever been afraid of discovering something totally unexpected? No. No.
It can be scary.
That is something I think all scientists dream of. There are times in physics down here that times in physics in general that I've felt like I need to really learn some new things and get going, and that I'm a little bit behind the rest of the group, but you catch up. Eventually you learn that you can always learn to do what you need to do.
Given the limited amount of drinking water, how much water comes from the supplies? Is there a quantity of water provided for each of you?
So this is actually not a problem. So the water that's limited down here is actually limited by fuel. We dig a hole in the ice, we make a big bulb, and then we melt water down in that bulb. And ice, as it turns out, is a very good insulator. And so we then pump that water up, and we have some of the cleanest water on the planet. I think it might be the cleanest water on the planet that we can drink. It is limited because we have to conserve fuel. We're limited to 2 2-minute showers per week, which you do in fact get used to, but I'm really looking forward to going back to slightly more showers than that. Otherwise, no, they encourage you to drink as much as possible because the South Pole is the driest desert in the world. And so you get dehydrated very quickly down here, and you don't want to get dehydrated.
Like the astronaut, when you come back, you will have to do some medical exams or a kind of isolation?
No, that's not a requirement on the way back. We thankfully are at full gravity the entire time, so our bodies aren't changed quite as much by the experience. We do receive typically flu vaccines and other stuff as we're going back just to try and minimize our exposure, but yeah, that's about the extent of that.
Okay, we'll ask you a question. How is it going to the South Pole? So which kind of selection and training did you experience to be selected to go there? First questions. And then the second question, how does the trip work? So how do you reach the South Pole?
So the selection, at least I can only answer for the IceCube selection. And the way that works is they have an initial phone interview in which they try to assess if your ability to do sysadmin tasks and electronics tasks and what you need to do to repair the IceCube detector is there, or if it's at least trainable. Then typically they will invite you to an in-person interview, which takes place over 2 or 3 days in Madison, Wisconsin. And they're very cagey on what exactly they're looking for, but you go out to lunch, you interact with other people, and eventually they select 2 people. So it's actually a pretty good time. You get to eat well. Madison has really good food, so I'm not complaining.
But then you will undergo a training, no? How long does it take, this training?
Oh, yes. Then, yeah, after you get through the interview process, sorry about that, you undergo about 2.5 months of training, where they will train you on all the systems. I think we have, 40 some servers that you all do different things in there that you have to train on, in addition to our 86 DOM hubs, which are all custom hardware that you have to know how to repair and deal with. So they spend a lot of time training you on all the programs and interconnections of the network, and importantly, how to minimize the amount of downtime IceCube has. Because we only see 10 neutrinos a year, and we're also on the lookout for very interesting events like supernova and gamma ray bursts. And we do not want to miss one of those. So we try to maintain our uptime at better than 99%. We're usually better than 99.8 or 99.9% up.
And the trip, how does it work? So
the trip. So the trip, you first, typically, again, this year's different, but typically you go to Denver, and you are trained a little bit about South Pole there. I was trained on the fire team. So we learned to put on bunker gear and SCBAs and use a fire extinguisher and, make us not completely incompetent at responding if something were to happen down here. Then we went to team building, which was 3 days of interacting with your fellow Winterovers and getting to know them. Then from there, we flew to San Francisco, where we connected to New Zealand. And then in Christchurch, New Zealand is kind of the staging point for the US Antarctic program, at least McMurdo in the pole. Palmer is on the other side of the continent, and it's served by a ship from Chile. So you go to Christchurch, you spend some time there, you pick up your Big Red and all your other cold weather gear, your extreme cold weather gear. And then from there, you fly to McMurdo in a gigantic plane called a C-17. At McMurdo, you stay from anywhere from 12 hours to a week or more. You had to stay more, month. And you wait for a plane to the pole. And then the plane to the pole is either a Basler or an LC-130. So it can take more than a week in a normal year to get to the pole, much less with quarantine procedures and everything else going on, and minimized flight schedules and everything else.
Thank you. So what kind of works do you do there?
What kind of work? So when we're fixing the detector, usually one of several things has happened. Either something has gone wrong with one of the DOM hubs. This can be anywhere from its GPS clock failing to one of its power supplies for the DOMs failing to some sort of internal software issue. And then in that case, we go out and we replace what we need to replace, and we may then later repair the replaced piece. Like I said, this is all custom hardware, and even if it weren't, we don't have resupply for 8 or 9 months out of the year. So that's one kind of problem. Another kind of problem, the kind you hope for when you get paged at 4 in the morning, is the kind that can be fixed over the computer. So some piece of software has crashed and needs to be restarted properly, or something else that can be solved without walking a kilometer in minus 60 C temperatures to the ICO.
what time is it for you now? So the sun is up all the time, but you know, for us it's it's 10 o'clock in the morning, but I believe that for you it would be in the middle of the night and you woke up especially for us. Is this true?
It's thankfully we're only 12 hours ahead of you. It's about 10 p.m. So
Okay.
it's late, but it's not the middle of the night. Don't worry.
Okay, good. So I will keep you another couple of minutes because I see nice pictures on your back, no? So these are historical pictures which tell us a little bit the story of the South Pole. I see one which I recognize, which is the team of Scott, I believe, reaching the South Pole. Can you tell us something about it?
So Scott, as you may know, was actually the second person to reach the South Pole after Amundsen, and that's the name of the base, the Amundsen Scott South Pole base. And he reached it. He was about a month late. He reached it, I believe, January 5th, was it? January. He reached it in January. Scott. Yeah, he reached it in January. He turned around and he tried to get back to McMurdo as quickly as he could. Unfortunately for Scott, the weather turned on him relatively close to the pole, sometime in March, and his team was not able to make it back to the coast, and they perished on the way back. Yeah, it's very sad.
That picture is
showing. You can actually see the what?
Excuse me, I'm sorry. That picture is possibly showing the 3 people from Scott's team reaching the pole that found the tent of Amundsen. Is that correct? The tent, which is in the picture, is probably from Amundsen. No, that also possibly didn't help to reach all the way to South Pole to be the second one.
Yeah, Scott did find a tent with Amundsen there, and he found a letter to take back. Amundsen did not know that he would make it back to the coast and asked Scott to bring a letter back to his king in the event that Amundsen didn't make it. He found a few other things. I want to say they left him. They left him like some meat or something. They left him some gifts, and they were, I believe, about a month later than Amundsen. I think it was in Scott. What? Yeah. Okay, yeah, so Amundsen was December 14 and Scott was January 18. So just about a month later. And that was enough of a month to turn the weather on him. Yeah.
I also see another picture.
No.
Excuse me, I'm sorry. I also see another picture, which is possibly from the first station, no? I can't really see very well. There is a picture laying on.
Yes.
And so the first station is not like the one that we see nowadays, no? It is even more extreme and more adventurous.
No, it's incredibly extreme. So this, and this is a picture of the crew from the first station. This crew was, I believe, mostly Navy. And as you can see, the Antarctic Treaty had not been signed yet because they have a dog. That's one of the most relevant parts, at least personally to me, of the Antarctic Treaty, is you are not allowed to introduce animals to the South Pole. And as a result, we can't have a dog down here during winter. It's done to protect against invasive species, and I understand why they do it, but I still kind of want a dog. But no, that was the first naval base. It's something we call Old Pole. It actually is buried out in the dark sector now, or out near the dark sector. So it was incredibly extreme. We've learned a lot about the age of Antarctic exploration, even with planes. There were actually far more accidents with airplanes back then, before they learned really how to deal with the ice and the weather and everything safely. So it was incredible. You're right. It was very extreme, and it was a very different time. But that's Bravo, the dog.
Nice, thank you. There is another question. During winter, there is no sunlight, but is it completely dark or snow reflects a bit of light? Maybe coming from outer space or moon?
So it's a great question. As it turns out, you're right. The moon, when the moon is up outside, it is easy to see. There's really no issue seeing everything. You can see the ICL from the station. You can see in every direction. The snow being white actually really helps that because it kind of bounces some of the light back up and scatters it. Now, when the moon is down, it's very hard to see into the distance. We actually keep red lights on pretty much all of the buildings to help people navigate. Although it has been the case for me that sometimes the auroras were bright enough to pretty much see by.
Yeah, also the stars reflect off the ice is also it is not very good. Not completely dark.
Yeah.
I still see.
Yeah, Martin there is saying that the stars do reflect off the ice and it is not completely dark, but it's pretty dark. It's pretty dark out there. Getting a good picture does require a good 10-20 second exposure.
We have another question. So we're taking all your time. Thank you so much. If
No,
you
take as much as you want. I love this stuff.
The next question is, has this experience met your expectations?
You know, it has. Now that I think about it, it's about what I expected it to be. Honestly, there's probably slightly less drama over the winter than I was expecting there to be. So all told, it was really good.
Are there any moments of tensions or reasons for people not to go along well in the station? And in case, how do you handle this?
So there are, of course, people do have their disagreements and they have their incompatibilities. The way that this is part of the team building and part of the pre-training is, you know, it sounds a little bit like what you learn in kindergarten, but there's a lot of, you know, how to resolve conflict by starting with I feel words and by describing where you are and trying not to be accusatory and that sort of thing. It you know, like I said, it sounds silly when you talk about it from in the North, but it works pretty well. And nobody really wants there to be conflict, so everybody works very hard at letting things roll off of them.
You said that you managed to grow a strawberry last winter. So was it one strawberry? And if yes, who got the strawberry?
It was more than one strawberry, thankfully. Otherwise, there might have been a fight. It was actually several very small strawberries. And mostly it was volunteers in the greenhouse that ate them. We didn't grow enough for the whole station, so we just had them.
Are there any more questions for John and Martin? Okay, I think that there are no more questions and I really want to have some rest now. And it was really, yes. Oh, okay, sorry, just one question. Are there other similar bases belonging to other nations? How are the relations with them?
So there's quite a few nations down here with bases. Most of them are on the coast. Probably the most similar one to us is Vostok, which is run by the Russians. But there's all kinds of bases all around the coast. And honestly, relations down here are very, very friendly, as far as I can tell. Pretty much everyone down here knows that they are, you know, this is a difficult place and nobody wants anything bad to happen. Everybody tries to be self-sufficient, but everybody's willing to help out. And it does sound like we're coming to an end, like you said, but I wanted to make sure I got a chance to thank everybody for being here and listening. I really enjoy doing these things, and I'm so happy that people are interested to talk about stuff.
Well, it's certainly a unique experience, so thanks to you. There is one last question. When you go home, do you feel the difference in breathing?
So I can say when I went to McMurdo, I felt a little bit of a difference. You felt really like Superman for a few days. You Martin, did you notice it?
Yes, especially when you go back to sea level, then for a few days you're breathing very well, and you're thinking, yeah, you can do anything and climb the mountains, and but actually that vanishes really quickly. I think. I think within a couple of days you kind of lose this. You can lose it, and then you're just basically a normal person again. So yeah.
Yes, I experienced the same, even if I stayed only for a month. I really felt Wonder Woman climbing up Discovery Hill. I felt like, wow, but it lasted only a couple of days. But what I also experienced is going back to New Zealand. When I went off the plane, suddenly I could smell everything. So I felt completely like a shock wave of odors, perfumes. And this was for me a very strong experience as well, because at South Pole, essentially there is no nature, nothing. And I really felt this difference. Suddenly nature and green smells were really overwhelming.
I've heard that. I haven't gotten off the ice yet, but I'm really looking forward to greenery again.
So I have the experience when I came back in 2017 from the ice. The first thing when I exited the airport in New Zealand, the first thing that I was smelling was flowers, because when you come off the ice in November, it is springtime there, and the first thing what you smell is kind of flowers, and what you hear are birds. So that's was really nice, and then and then being able to eat a lot of fruits again was really nice. So yeah.
Okay, Chiara and Sabine, do you want to add anything to our experience today? Do you want to say anything or comments?
No, I think I just want to say a really huge thank you to the two Winterovers that were so patient to answer all the questions, and it was really interesting. I have to admit, one of the reasons I organized this meeting was because I was interested myself in meeting you guys and hearing the answers. So I think that was a really great experience, and thank you so much for that. Chiara, I don't know if you want to add anything.
Thank you so much. It was amazing. I actually spent many hours working in underground, but so I recognize some kind of experience that you spoke about, but life in South Pole is really amazing. Thank you for sharing with us something. Thank you very much.
Okay. Thank you also to Elisa, of course, and Katarina that suggested and organized this meeting. And thank you so much for this great opportunity and for all the work you did to make it happen.
And thank you also to all you students because you managed to ask many interesting things. And I hope that you got inspired by this experience.